What if some places were written outside the laws of science? We live in an age of extraordinary discovery. Our telescopes peer into the cradles of distant galaxies, and our microscopes decode the very building blocks of life. We've mapped the human genome, charted the deepest ocean trenches, and landed robots on Mars. We are, by all accounts, a species that explains things. We find patterns, we formulate laws, we solve puzzles. It's what we do. But what happens when the puzzles refuse to be solved? When the patterns break and the laws of physics seem to bend or perhaps not apply at all? There are corners of our own world, our home planet, that continue to defy our most sophisticated instruments and our most brilliant minds. Let's begin with a classic, a legend that has haunted the imaginations of sailors and aviators for decades: the Bermuda Triangle. This stretch of the North Atlantic Ocean, loosely bounded by Bermuda, Florida, Puerto Rico. Statistically, it's a heavily trafficked area for both ships and planes, and while many researchers argue its accident rate is no higher than any other comparable part of the ocean, the nature of the disappearances is what captures our scientific curiosity. Over 50 ships and 20 aircraft are said to have vanished without a trace. No wreckage, no distress calls, just silence. The stories are chilling. Consider the words of one pilot, recorded in a final transmission before contact was lost.
Everything is wrong. Strange.
The ocean doesn't look as it should. What could make a seasoned aviator feel so disoriented? What could make the very ocean appear alien to them? It's a statement that sends shivers down the spine, not because it's paranormal, but because it's a cry of profound confusion from a trained observer. We are compelled, as scientists, to investigate such anomalies. The data demands our attention, even when it leads to uncomfortable questions. One of the leading naturalistic explanations involves geology. The theory posits vast deposits of methane clathrates on the seafloor. A sudden shift in temperature or pressure could cause these deposits to erupt, releasing a massive plume of gas. This eruption would catastrophically reduce the density of the water. A ship caught in such a plume would lose all buoyancy and sink in seconds, pulled beneath the waves so quickly that a distress call would be impossible. It's a plausible, elegant, and terrifying hypothesis. For aircraft, the methane theory extends. If this massive gas bubble burst into the atmosphere, it could create a highly flammable, oxygen-deprived air pocket. An aircraft flying through it could see its engines stall or, worse, ignite the methane, causing an instantaneous explosion. This would explain the lack of wreckage and the sudden loss of communication. The evidence for such massive, spontaneous eruptions, however, remains circumstantial. Imagine you're trying to sleep. The house is quiet, the streets are still, but there's a sound. A faint, persistent, low-frequency drone. It's not a refrigerator. It's not the plumbing. It's just there. You put a pillow over your head, but you can still feel it, a vibration in your bones. For a small percentage of residents in and around Taos, New Mexico, this isn't a thought experiment. It's a maddening reality. This is the story of the Taos Hum, an acoustic anomaly that has baffled scientists and tormented hearers for decades. The phenomenon was first widely reported in the early 1990s, prompting a flurry of investigations. Teams from the University of New Mexico Sandia National Laboratories and Los Alamos National Laboratory descended on the town. They brought sound monitoring equipment, microphones, and geophones, determined to pinpoint the source of this hum. The results were, to put it mildly, frustrating. The equipment detected nothing. No anomalous acoustic signal. No seismic vibration. Nothing out of the ordinary. Yet the hearers insisted it was there. This is what makes the hum so scientifically perplexing. It's a physical sensation reported by credible witnesses, but it is undetectable by our instruments. This has led to a primary theory: infrasound. Infrasound is sound at frequencies below 20 Hz, the lower limit of human hearing. While we can't hear it in a traditional sense, infrasound can be felt. It can cause anxiety. Welcome to Racetrack Playa, a dry lakebed in Death Valley, California. It is one of the flattest, driest, and hottest places on Earth. And here, something extraordinary happens. Rocks, some weighing hundreds of pounds, appear to move on their own, carving long, elegant tracks in the cracked mud surface. For decades, these sailing stones were a profound geological mystery. There were no footprints, no signs of animal intervention, no signs of human intervention. Just a rock and a trail stretching out behind it, sometimes for hundreds of meters. The sight is surreal. It's as if the fundamental rules of inertia and friction have been temporarily suspended. You see a massive dolomite boulder sitting peacefully at the end of a perfect curved path. The path shows where it has been, but gives no clue as to how it got there. There is a place on Earth more isolated, more alien than almost any other. It is buried beneath 4 kilometers of solid Antarctic ice. It has been cut off from the rest of the world, from light, from air, for at least 15 million years. It is a world unto itself. Its name is Lake Vostok, a subglacial lake the size of Lake Ontario. It represents one of the last true frontiers of exploration on our planet. The crushing silence and immense pressure there are almost beyond comprehension. The lake was first discovered in the 1970s by Russian scientists using ice-penetrating radar. They were mapping bedrock from Vostok Station, and the readings showed something impossible: a massive body of liquid water, trapped and preserved. The ice sheet above acts as a perfect insulating blanket, trapping geothermal heat that keeps the water from freezing, despite surface temperatures plunging to the coldest ever recorded. For decades, the challenge was how to study it. How do you access a pristine environment sealed for millennia without contaminating it with modern microbes? The Russians began a slow, painstaking drilling project. For years, they drilled deeper and deeper, stopping just short of the lake to avoid contamination. The ice cores they extracted were a treasure trove, a frozen timeline of Earth's climate going back hundreds of thousands of years. But the real prize lay below. Finally, in 2012, the drill bit broke through. They had reached the lake. We have journeyed from the supposedly cursed waters of the Atlantic to a maddening hum in the desert. We've watched stones glide across a dry lake bed and peered 4 kilometers beneath the Antarctic ice. In each of these places, science has been our guide. We've applied logic, deployed technology, and formulated theories. For the sailing stones, we found a beautifully elegant naturalistic answer. For the others, the answers remain fragmented, contested, or completely out of reach. The Bermuda Triangle, the Taos Hum, Lake Vostok, remind us that for all our knowledge, there are still blank spaces on the map of our understanding. These places are not failures of science. On the contrary, they are what drives science forward. They are the anomalies, the outliers, the data points that don't fit the curve. They force us to re-examine our assumptions, to invent new tools, and to ask more profound questions. They represent the boundary between the known and the unknown, and standing on that boundary is the most exciting place a curious mind can be. The universe, and our own planet, is under no obligation to be simple or to make sense to us on our first attempt. We have tools, theories, and brave minds. But these places remind us that the world still holds secrets. For now, the answers remain out there, waiting. Tell us which mystery you'd explore next.